激动，特别激动，他可能已经被我们思考这个正常到位，应该知道咱们什么水平。我的英语又不能用了，是那个学生版的呀，学生版，我下初三。
那边的可以少。我说为什么这个跟他不一样？因为有少，因为这个我就用它，因为我在哪干的吗？Yes, it is. How is it? It's 7 episodes. Please watch.
I think something wrong with the e-bills, right? Because e-bills the list, some PC is shut down. Some PC okay, some PC shut down. So I think e-bills charge is national trustable. E-bills charge okay, no problem. By the way, you can try because now I see the e-bills the name tag movable. I think it's something wrong when the install the program there's some operator. You will see whether we can update. click on the CFPBL, open that as a, what we say, the group. Then I go to view, then I go to configuration test. If I click on the panel configuration test, so you will pop up this framework. Alternatively, you also can go to the quick here. Then in the group as statistic, you can click on this Johnson test. Right? Then pop up this option. So under here you have three again, so Petroni, Gao, and Fisher. So again, the intercept, no trend. So refer to the alpha and also your delta in your test equation. So you assume, it means that you test whether there's a correlation with the intercept or trend or not. Then you click on this one. Because of this Petroni, there's a non-parametric approach. So there's a spectral estimation, and when you scroll down here, normally we will use this methods. Then you will make automatic selection for the band one. Then you click on OK. So once you click on OK, you will pop up this 11 statistic. So the X statistic is under this alternative, is homogeneous, right? Homogeneous, the rule for the as alternative less than 1. So out of this 8, how many are significant? So you can refer to the p-value here, right? P-value here. So how about different here? Investment CAPBAL. Let me check. Okay, so CAPBAL 1935, 1954. Okay, 200 and then 10. SIC. So this is also different, yeah? Oh, yeah. This, because I checked, is based on this no intercept, no trade, right? This third test set auxiliary regression. These are the third test set, the test equation. So this refers to number 3. So no alpha, no delta. That's why it's a difference with my statistic here. So is there any correlation? Yes, based on this first X statistic, actually all statistics actually reject the original. Because the p-value is significant, right? Reject the original, significant at least 10%. So for example, this one significant at 10%, and then these two significant at 10%, remaining significant at least 5%. So all these statistics actually reject the no correlation. So they support the p less than 1, right? P less than 1. Then how about the remaining these 3 group statistics? So for these 3 group statistics, so we still reject the no correlation as a first now. So it means that there is a co-integration in the long run, and the rho I is less than 1 as alternative, rho I. So this is a heterogeneous one, so the rho I is less than 1. So at least these 2 out of 3, right? 2 out of 3. So majority shows that there's a significant means a correlation in the long run. There's a correlation in the long run. So how about statistic which consistent with the lecture notes? You go to the correlation test and then check for the box intercept and no trend, right? Yeah. So no trend on it. So no trend, but with the intercept. The first case to check whether there is a correlation with the intercept or not. That's based on SIC and based on the automatic for the non-parametric equation. So here, so these 3, yeah, consistent. So these 3, 4 is not significant at all. So out of this 8, 4 is significant. Only 4 significant. 1, 2, 3, 4. So this unweighted, this weighted, right? So out of this 8, only 4, 50%. So still quantified, right? Yeah. Still quantification acid for these 3 variables. So there's a quantification acid for these 3 variables. And against 2 out of 3 have P1, Pi actually less than 1. So not only that, right? You also can see the individual result. You also can see the individual result because once you scroll down, you can see the augmented Dickey-Fuller result because this one is actually based on the Engel-Granger, right? Engel-Granger to solve the serial correlation, means residual-based correlation test. So you can see the individual 8 atoms. And also together with the Phillips parents, these are non-parametric things now. And that's why they choose based on the band 1. And the augmented Dickey-Fuller is choose the backband with the maximum length for all these 3 cross-section. Means for our 10 firms here, 10 US firms here. So now, so that's the things like, okay? So how about another test? See whether there is a correlated in the long run with the intercept and also trend or not. So you can go to the correlation test and then choose the intercept and trend. Click OK. So again, similar with our previous result, still 50%, right? Out of this 8 statistic shows that there is a correlated in the long run, and 2 out of 3, right? Support the between means that between dimension means that the rho I is less than 1 for all the 10 something like for all the 10 cross section. So how we going? What's the details here? So the top portion actually your type of the test, your Hirschsprung, and also the exogenous variable. Is it true? Yeah, because it refers to the patroni and then the variables and also sample and also how many cross section and also your null hypothesis. There's no correlation, right? As a Hirschsprung for the patroni test. So remember that what is the Hirschsprung? No correlation in the long run. Then this one is a patroni test statistic, which against alternative either homogeneous or heterogeneous alternative. This refers to the within and this refers to the between. So what's the difference? This homogeneous, right, is the rho is less than 1 now. It is a common AR. But this one is an individual AR. So autoregressive. So this one actually refers to the common one, right? Common coefficient. Actually refer to the P equals to PI is less than 1. Right? So refer to this. Yeah, this one. Means common, right? So still the same. But this one is individual PI less than 1. Or heterogeneous as an alternative. That's why I call between individual AR. So why they want to bring out this issue, right? Because difference because we have 10 cross section, right? So the issue in the panel analysis is what should include in your panel. So remember our discussion is one of the challenging part in the panel analysis is should I pull this 10 firm into one panel? Right? Should I pull this 10? This is just a 10 firm, right? How about you have 100 firm? You have 200 firms. So which firm should be excluded out? Which firm should be included? So that's a challenging part here. That's why in the panel usually test we talk about the cross section dependence. Because the respective firm has their own characteristic. We should not include them into together, right? So we're going to discuss this challenging part in the last lecture to talk about the issue in this panel analysis. So now, so what we can do the conclusion. So 5 out of 11 reject the null of no correlation at 5%, at least 5%. So based on this, we want to test for the test equation correlated by including just the intercept. What we conclude that is how many? 5. Yeah, 1, 2, 3, 4, 5, 6, right? The no one here with 5. So because it's 1, 2, if say 5%, so this one not included. So 1, 2, 3, 4, 5. So 5 out of 11 shows that there is correlated in the long run. Okay, at 5% significant levels. So this is our conclusion. So again, you can look at that individual if you want to check the rule, right? So these are the individuals, they are those. So we talk about the auxiliary cross-sectional result. So you can show in the intermediate calculator if you want to use this information. Are you okay? Still struggling with your English studying, right? Because I think that when they install the English studying, maybe they not update the recent operation yet. So I think we need to update the English studying. Are you on, right? Maybe you click on this one window, right? Or maybe option here, auto update, maybe you can solve the problems, right? So okay, so now we move to the second one. The second one is a count. So these are also based on the Angel Granger based correlation test. So what is the difference here? So So the gown follow the same basic approach like the Petroni, but specific the cross-section specific intercept and homogeneous coefficient on the first stage regression. Yeah, this gown try to modify that because this one is 999, right? How about the Petroni? Petroni is earlier than basic Petroni. Petroni somewhere in 999 also, 2004. So both also come in the same years, right? 999 also. So let's see how the gown work, right? So this gown follow the same basic approach like the Petroni, but he bring out the cross-section specific intercept. So just like the one to individual firms, for our case, individual firms going to have their individual intercept, but homogeneous coefficient. Homogeneous coefficient on the first dash regression. So let's see how it works. So again, you come out with your variable y and also x, and individual intercept, right? So you can see your alpha become I here, subscript I. So how about the previous one? Let me check. The previous test don't have, right? You don't have the. Oh, here still have alpha, right? Yeah, but we assume, yeah, heterogeneous intercept also. So where is the difference here? So let's see what is the idea behind gown. So we have equation number 4, and the first stage, right? So we assume these two is followed by y equals to the yit minus 1 and x equals to xit minus 1, and require the alpha I to be heterogeneous, but this one is homogeneous. So they are same. So homogeneous Schur coefficient. So homogeneous across the cross section. So this one try to modify the Petroni test equation. So this one allowed to be hetero, but the coefficient for this Schur, it means that Schur coefficient assumed to be homo. So pull the Schur coefficient same, and setting all the train coefficient to be 0. So this is under the gown. So what is the gown do? So the gown runs either the pull auxiliary regression. So auxiliary regression, so the residual against on the left for the residual in the panel setting, and test the row here. So these equations, this residual, right? And also the augmented version. So against we have the changes for the left for this residual. So what is the H now? No cointegration. So and this gown, right? They have a 1, 2, 3, 4. Yeah, 4 statistics. So let me see. So you will come up with like this, like you come up with the ADF. You come up with the ADF and then here. So following the statistic like the Dickey-Fuller for the P, Dickey-Fuller for the subscript T and the P star, and the T star here. So for the root greater than 0, and then NDF. So this one just want to they're still based on the idea that they will produce you the one statistic, and then to show that whether there is cointegrated or not. So under the H now no cointegration. So again you need to choose the newly best. It means that also involve the non-parametric, right? Non-parametric. So now let's see. So you can go to the view here, and then go to cointegration, and you choose the panel cointegration here. Then you choose the second option, the gown and the gradual base. Then only individual intercept. Because under the gown, it's not allowed to put into to test the cointegrated with the train or not, or no train. That's why you will see there is a statement here. And setting all the train coefficient to 0. So this is a different compared to the Petroni. Petroni allowed for 3 different test equations, right? Intercept the train, and then intercept as well as no train, no intercept. But this one just the individual intercept. So other than that is the lag length. You still remember is an agent brancher, so we have to choose the appropriate lag. So based on SIC, and then maximum lag, based on maximum lag, and then choose the appropriate lag. And this is the spectra based on the universe, then you click OK. So once you click OK, you can take a look the test equation. This is the so the big difference right compared to the Petroni, because Petroni proposed that there are 11 test statistics, but Gao is based on this augmented version, the difference for the residual, and then runs on the lag for the residual, and also the residual lag for the residual here. So this is the test equation. This is a test equation that we study in a time series, but this is under the panel settings. Then based on this test statistic, again they compute the ground residual in the test statistic. So the big difference is no longer from here, is that because they're based on the own test statistic, then they come up with the ground configuration test. So here, significant at 10%. So what you can conclude from the result here? So what you can conclude, so reject the rationale of no configuration in the long run. No reject that, because if you believe that there is a 10%, so there is no configuration in the long run by using 10% significant levels. Then how about 5%? If you based on 5%, right, then there is no configuration. If you based on 5%, there is configuration, right? So there is configuration. So there is the difference here. So what else you can study, right? Later on, we were going to discuss about this Johansson configuration test together with the single equation. So what else? Actually, in the EDUs, right, we also got the causality as well. So before we move to the second part, what else? Yeah, configuration and long run covariance. If you click on this hashtag number 3, right, it's a Fisher. It's a Fisher, then you can, these are the things we're going to discuss after the break times. So, by the way, right, so normally we just deal with the single equation approach, right? Yeah, Petroni, and then the Gao, actually it's a single equation approach. So after the break, we're going to deal with the, like the Johansson type. So the difference between this Gao, Petroni, and also this Fisher Johansson. So just like the engine Granger is based on single equation to study about the configuration. But for the Johansson, it's based on the multivariate, right, multivariate approach. And but this one is combined with the in a system. It's different compared with the Gao and also the Petroni type. So okay. So let's see the paper I uploaded in the spectrum, right? Take a look. So have you go through the papers I uploaded in the spectrum actually? No, right? Just look at the lecture slides. So, for example, you can study this one in published in 2015. So this one is talking about the panel configuration and also the causality. So when you scroll down, right, you can take a look how people report the result, right? Report the result and what is the motivation. So they discuss about the configuration test. Configuration test, like how they discuss about the Petroni, right? Petroni test, panel configuration, right? There is a Petroni test. So this Petroni test is it's derived the 7 panel, and then with the step, for example, he rewrite this equation with their dependence and also independence variables, and also with the intercept and with the time frame, right? So with the either is a fixed specific, firm specific fixed effect, and also the time frame here, deterministic trainer. So just now, like if you say on the test for the configuration with no train and no intercept, so you just go back to the model without the intercept and the train. So it depends on how you test your configuration, and the estimated residual which duration for the long run relationship to test for this one. Because once you estimate the models, then if you actually refer to this residual, right, and testing the residual, residual here, testing the rule whether equals to 1 or less than 1. So here we have a homogeneous as an alternative or heterogeneous as an alternative. Right? So I have either is a homogeneous panel or heterogeneous group. Right? It means homogeneous or heterogeneous. So you get the single equation, right? So single equation. So if you want to study about the co-integration, right? So how are you going to study the co-integration test? So let's see here. If you want to touch on this. So maybe we take a break, then we come back here to talk about the Johnson and also the co-integration test. So by the way, you can spend some time to go through the journal articles here at the Archimedes 2007. So you can take a look how people to bring out the panel integration approach. People will just test the panel unitary test, right? Test the panel unitary test for all the variables. Then they will run the panel co-integration test. Like report all the 4 plus 3, 7, right? 7 test statistics here. It means they just report the 7 statistics, but not the weighted one. So it shows that all the variables actually co-integrated in the long run based on these 7 statistics. So they, I think this paper, right, I will list them, divide the sample. This paper that divide the OECD countries as a panel and then non-OECD, right? So OECD, non-OECD, as well as all the countries. So they have a different, because they believe that they should have a different perspective from the OECD and also from the non-OECD, as well as in the aggregate level. So they have 3 different panel, and then they also report the panel benefit OS. So actually after you run the calculation, right, you can report the because if we did not talk on this panel unit, I think in the initial panel analysis, we straight away go into the random effect, right, and also OS. So if let's say we found that the variable actually I1, then you also found that there is a co-integrated in the long run. So the fixed effect, random effect, as well as the pool OS is no longer valid. So in that particular scenario, we have to use that regression that accommodate the I1 variables. So in this field, so either researcher will use the fully modified OS or the dynamic OS, which normally used to tackle the I1 series. So you can see this researcher used the dynamic OS to report the coefficient. By using a different proxy for the dependence variable. So the dependent variable is Y, right? But they use different proxy for the dependent variable together with their independent variables based on the dynamic OS. Because they found I1, so they proceed with the correlation test, and then they found there is a correlated, so they proceed with the approach that handle the I1 series. So they report the dynamic OS, right? And then eventually they will report the panel causality to study whether for these 3 different groups, OECD, non-OECD, as well as all the countries, so the direction is from the DF go to the D1 or the other way around. Or they have a bi-direction. So based on the panel causality test. So we have to be cautious. Even though our series is I0, right, we still can run the panel causality. If the series I0, we just proceed with the conventional study the causality in the level form. If there is the I1 series, then we have the first difference. So there is another idea behind the panel causality that handle the I1 series. When the first difference of variable, then only the result will be not biased. If not, right, our result will be spurious. Even though in the causality also will come up with a spurious result if we did not handle the I1 series properly. So that is the idea behind it.
你是那种吗？
So thinking about
没怎么
break.
做。那你最近在忙啥？
So this is another paper.
出去玩完回来以后就只想写个啥不想。